नमस्कार दोस्तों, मैं शिवानंद उपाध्याय आपका स्वागत करता हूं हमारे YouTube चैनल केमिस्ट्री एकेडमी फॉर IIT JEE एंड नीट। आज हम एक सरल इंपॉर्टेंट टॉपिक पढ़ने जा रहे हैं, balancing of redox reaction. Redox reaction is a reaction in which oxidation and reduction takes place simultaneously. There are many type of redox reaction, but today we'll learn how to balance an intermolecular redox reaction. तो अगर हम intermolecular redox reaction की बात करें, then in this intermolecular redox reaction, one chemical species will give electron, the other chemical species will take electron. So now we have to learn how to balance an intermolecular redox reaction. In balancing any redox reaction, there are three steps involved. The first step is balance those atoms whose oxidation state is changing. Second step is balance the charge. In acidic medium, we'll add H plus on appropriate side. On basic medium, we'll add OH minus on appropriate side. And the third step is balance those atoms whose oxidation state is not changing. These three steps is involved when we are balancing half cell reaction or we are balancing the complete redox reaction. We are starting with one example. Iron plus N2H4 plus H2O is converted into ferrous hydroxide plus ammonia. So if we see the oxidation number or oxidation state of different elements present in this chemical reaction, on the left hand side there is iron which is in zero oxidation state. In N2H4, nitrogen is present in -2 and all hydrogen atoms are present in +1 oxidation state. In water, oxygen is present in -2 and hydrogen is present in +1 oxidation state. In ammonia, all hydrogen atoms are in +1 and nitrogen is present in -3 oxidation state. In ferrous hydroxide, iron is present in +2 oxidation state and oxygen is present in -2 and hydrogen is present in +1 oxidation state. So in this reaction, iron is changing its oxidation number, nitrogen is changing its oxidation number. There is no change in oxidation number of hydrogen and oxygen. So the above reaction can be divided into two parts, oxidation part and reduction part. So in oxidation part, iron from zero oxidation state is moving to +2 oxidation state. So first we'll try to balance the reaction, oxidation half cell reaction. So first we'll balance the atom whose oxidation number is changing. Iron on the left hand side is 1 and on the right hand side is also 1. So the atom who's changing its oxidation state is balanced. Now when iron is moving from 0 to +2, it will lose 2 electrons. So on the right hand side we'll add 2 electrons. Now we have to balance the charge. So in order to balance the charge, since in this medium ammonia is there and the medium is basic, so in order to balance the charge, we have to add 2 times of OH minus on the left hand side. 2 times of OH minus on the left hand side. So charge is also balanced. Now we have to balance those atoms whose oxidation number is not changing. So hydrogen on the left hand side is 2 and hydrogen on the right hand side is also 2 and oxygen on the left hand side is 2 and oxygen on the right hand side is also 2. So we can say that the oxidation half cell reaction is complete. We have balanced iron atoms whose oxidation number is changing. We have balanced the charge and we have also balanced hydrogen and oxygen atom. So oxidation half cell reaction is balanced. Same way we'll try to balance reduction reaction. So in order to balance reduction reaction, nitrogen is changing its oxidation number from -2 to -3. There are 2 nitrogen atoms on left hand side, so we'll multiply here by 2 in order to balance nitrogen atom whose oxidation number is changing. Nitrogen from -2 is going to -3, so one nitrogen atom is taking 1 electron. There are 2 nitrogen atoms, so they will take 2 electron. Now in basic medium we have to balance the charge. So in order to balance the charge, we will add OH minus on the right hand side. So we have completed 2 steps. First step is we have balanced nitrogen atom whose oxidation number is changing. Second, we have balanced the charge. Now we have to balance those atoms whose oxidation number is not changing, that is hydrogen and oxygen. On the right hand side, there are 2 oxygen atoms. There is no oxygen atom on the left hand side since this reaction is taking place in aqueous medium. So in order to balance hydrogen and oxygen, we can add H2O molecule on left hand side. On the right hand side, there are 2 oxygen atoms. So in left hand side, in order to balance the oxygen atom, we should write 2 times of H2O in liquid state. So now we can count hydrogen atoms. On the left hand side, it is 8. On the right hand side, it is also 8. So we have balanced nitrogen, we have balanced the charge, we have balanced hydrogen and oxygen. So reduction half cell reaction is also balanced. Now after balancing oxidation half cell reaction and reduction half cell reaction, we should check the number of electrons participating in these half cell reactions. So the number of electrons in both is 2. So already the equal number of electrons participating in this reaction. So now we can add these two reactions. So on adding these two two reactions, we can write that iron metal plus N2H4. 2H minus on left and right will cancel out. So on the left hand side, I can write 2 times of H2O in liquid state. On the right hand side, we can write ferrous hydroxide FeOH whole twice plus 2 times of ammonia. So this is the overall balance reaction. When we are balancing this reaction, we know that in overall redox reaction, there are 2 electrons participating. Meaning of X factor or N factor. So when we are discussing meaning of N factor or X factor in a redox reaction, it is equal to the number of electrons lost, or it is equal to the number of electrons gained by one particle of a chemical species participating in a redox reaction. Like in this particular reaction, if I am discussing that what is the X factor of iron, because iron metal is losing electrons, so we can say that X factor of iron is equal to 2. It is losing 2 electrons. Same way we can say that N2H4 is gaining 2 electrons, so X factor of N2H4 is equal to 2. So if we know the X factor, then we can discuss about the equivalent weight. Equivalent weight, if we are defining, we can say that equivalent weight is equal to molar mass of the chemical species. Molar mass of the chemical species divided by X factor or N factor. So suppose if I am saying that what is the equivalent mass of iron participating in this intermolecular redox reaction, that is equal to atomic mass of iron divided by X factor 2. Same way we can say that what is the equivalent mass of N2H4. N2H4 is a molecule, so we can write that is equal to molar mass of N2H4 divided by X factor 2. So what is the meaning of equivalent mass? Equivalent mass is the mass corresponding to 1 Faraday charge. 1 Faraday charge is the charge on 1 mole of electron. So when we are saying that X factor of iron is 2, means when 1 mole of iron is oxidized to ferrous hydroxide, it is losing 2 moles of electron. So corresponding to 1 mole of electron, what is the mass of iron involved? That is atomic mass divided by 2. 56 divided by 2, 28 gram is involved for 1 Faraday charge. Same way we can say for N2H4, that when 1 mole of N2H4 is reduced to ammonia, it is taking 2 mole of electrons. So the molar mass of N2H4 corresponding to 2 Faraday charge. So for 1 Faraday charge, the mass involved is equal to molar mass divided by 2. दोस्तों, अगर आपको ये वीडियो अच्छा लगा तो प्लीज़ हमारे चैनल को लाइक एंड सब्सक्राइब ज़रूर करें